Kia ora koutou. Welcome to the latest TTEC Reboot webinar. We're going to give people a couple more minutes to join us. I can see people flooding in, so that's great. This afternoon's webinar is rebooting the papers and presentations from the TTEC conference cancelled back in June, hosted by ITS New Zealand. TTEC is our major annual conference every year. And for those of you who were there, it was quite a memorable occasion. We had to shut down after about 45 minutes, which was not ideal. That was back in, as I say, June, when we had a little COVID scare in Wellington. So everyone's nearly forgotten about that. We've been through much bigger trials and tribulations since then. But we're rebooting, and I appreciate everyone for sticking with us. There's lots of energy and interest in sharing these presentations with you, and so thanks very much for joining us as well. It's been a little bit of a journey, but we're here and looking forward to a real diverse range of presentations being covered today. The general theme of today's presentations ties to safety and equity, perhaps crossing over to sustainability as well, which was the kind of core three themes underlying the TTEC conference this year. We've got a number of speakers coming up today, actually 8 speakers, 7 presentations with 8 different speakers. A little bit more on ITS New Zealand, if you're not familiar with us. ITS New Zealand being the peak body for ITS, which is Intelligent Transport Systems, since 2004, and we've diversified more recently into future transport as well. So we're looking at quite a broad range of solutions. Majority of them are tech or tech-enabled solutions. There's generally a flavour of technology underrunning them at some point. We, as an organisation, advocate for the adoption of better transport solutions to increase sustainability, safety and efficiency of the transport network here in New Zealand. We link government, academia and the industry, the sector, and we're connected with a global network of ITS organisations. So we're a member of ITS Asia Pacific. You can see a little logo on that slide there. So through our international connections, we've got ITS Asia Pacific membership, and then we're connected to, I think it's now over 100 different ITS organisations from around the world. There's an ITS World Congress, which happens every year. We, of course, did not attend this year. It was in Hamburg in Germany, and I think China and USA coming up next. There's a snapshot of our gold and silver members. So we've got government, we've got engineering and transportation consultancies, we've got technology companies. We've also got research and education members. That's a new category we've recently added. And I'm very pleased to have University of Auckland and AUT on as our inaugural research and education members. If you've got any questions about membership, please do not hesitate to get in touch. There's a broader look at our entire corporate membership, and we have a number of individual members on as well. So on there you can see the kind of broad range, lots of IT services companies, mobility companies and organisations as well. Moving on, we've got another upcoming event actually coming up this week on Wednesday at 12 o'clock online again. We have our AGM, and this year we're very happy to have a guest speaker, Minister for Transport, Michael Wood. He'll be updating us on government's focus for transport, some of their recent milestones and achievements, and also announcing the Waka Kotahi Innovation Fund. I'm not going to take his thunder, and I'll let him tell you all about that on Wednesday. Hope to see you there. You don't need to be a member to join that event if you wish to attend. You can find the webinar details on our website. Moving on to today, our illustrious speakers are Andrew Gurr, CEO of Fusion Networks, Martin Knoche, CEO and founder of N3T, Jonathan Stirling, a systems engineer from Beca, who's in replacing Robert Boucher. Chris Rapson is a computer vision specialist at Auckland Transport. Ayesha is an engineer at Beca. Helen, a postdoctoral fellow at Lincoln University. Steve and Kirill both join us from Resolve Group. Now, the order of speakers today was to start with Andrew. He's unfortunately running late, so he'll be joining us sometime just after 4. So we will therefore be starting with Martin, and then the order will run as it shows there. So Martin, Jonathan, Chris, as I've just introduced them to you. We would encourage you to ask questions. We'll be asking questions after each speaker. We've got a good range of speakers today, so having the questions directly after each speaker. Just about time for 2 or 3 quick questions, really. Please post your questions using the Zoom Q&A. If you can, please give us a little context on where your question's coming from. Maybe where you work would help us give the answer that you're looking for. Again, we have a number of speakers, so please do also, when you're posting your question, please state who your question is for. That will help me as I relay them through to the speakers. And yes, please be concise. 1 question at a time, please. Cool. So, starting off today, as I've got Martin there highlighted, Martin will be our first speaker, and I'll invite Martin to share his screen now.
Okay. Well, thank you very much. Oops. Okay, can you see my screen?
I can indeed.
Excellent, excellent. Okay, so today I will be talking about road defect detection and traffic analytics using smartphones and roadside units powered by AI. A big part of the presentation was prepared by our PhD student, Catherine Cheng from AUT. Unfortunately, she's fallen in, so I'm holding that presentation, but that gives me an opportunity to also talk about how we're starting to commercialize her research. Oops. Okay. So what I will be talking about is briefly covering the transport challenges we're trying to address with AI and computer vision. And I will be talking about road defect detection, traffic counting, and then a little bit about better insights and better decision making. So the transport challenges we addressing are growing road network, growing expectations of road users and shareholders, but shrinking budgets. So how can traffic planners, road asset managers, and people paying in the transport sector cope with it? We think automation and digitization will be one part of it to help facilitate with the resources better outcomes. So Catherine started her PhD a year and a half ago, and she is working on 3 key questions. As you may know, AI needs a lot of data, and if the data input is not so good, then the output will not be good. So one of the first questions she's dealing with is with low contrast imagery you get from cameras moving across the road network. Then she's looking at developing deep learning methods to identify changes in space and time. And the third question she is dealing with is one I'm really quite excited about, is 3D image reconstruction. So the idea there is to identify the size of a road defect and potentially the depth, so that you can provide some input to operational crews how to deal with it when they come to site. So the first question is really about low contrast or complex weather condition changes in illumination, and sometimes you see sort of changes in the crack morphology. The second part she's looking at is trying to resolve multiple road defects in the same image. So you could have a pothole and a depression in the same image from your dash cam. So you need to resolve that spatially, and then when you drive over the same road defect again, later you want to have the time component in it as well. And then from a 3D perspective, that's something she is still working on, is how you can use stereo camera or LiDAR data to reconstruct 3D images to get what you can see here on the sides, where you see a pothole, and the idea is to identify the volume and the depth. So how's she going about it? After an in-depth literature research, she started to take public data sets, trained a region-based convolutional neural network, tested it, looked at the classification output, did a performance evaluation, and then iterated multiple times. In terms of identifying road defects, the way how she's doing it is she first identified, is this a good road, is it a bad road? If it's a good road, you don't need to do any real-time processing. It's a bad road, you're looking at cracks, and then you differentiate, is it longitudinal to traverse crack, that kind of stuff. So that helps to optimize the analysis. For those who sort of work in the computer vision space, so she has developed a residual pyramidal aggregation transformation. So it's basically stacking multiple networks on top of each other. And she has used quite a few public data sets from Germany, South America, Japan, and other places. And as you may know, you need to have lots of data for deep neural networks to function well. So, so she has trained her initial model with it, and then she came up with initial results. And it looks that the residual pyramidal aggregation transformation is performing quite well on several of those quality metrics. And again, I'm happy to answer questions for those experts. But what does it really mean in terms of practical work? So we've taken some of the output of her research, and I wanted to share with you our vision of a world without potholes. I don't know if you know the statistics in New Zealand. Every year about one person dies on our roads, and worldwide it's 1.3 million people, 50 million serious incidents or injuries on roads. Of course, not all through potholes, but good roads are safe roads. So the way how we go about it, we built a dash cam where you can turn any mobile phone into a road inspector, or a tool which detects road defects, true positives and false positives. So the false positives I explained in one of the previous slides. So what we then can do is we can then visualize on a map what type of defect has been where. We give the longitude, latitude, date, time, the vehicle it was recorded in, the speed it was recorded in. And if you do that for many devices, you do some statistical analysis, and then you can provide some input on what's a good road, what's a bad road. For each of those road defects, we will have an image. So basically what happens is when the vehicle moves over over a pothole, so basically the Z value goes down, we then wind back the video stream back and get the image of what the camera would have seen before it hit that road defect. And then we mesh that with the 3 dimensions of vertical and horizontal movement. And if you do some statistical analysis on that, again, you can then help to cross-verify and classify what type of road defect that was. Here's a little animation of what's that? A couple of days on one of the not so good roads in Whangarei, a road called Mill Road, where we had lots of road defects, and you can see sort of with a time lapse sort of some of those images. So in addition to mobile mapping of road defects, one of our customers approached us if we could help with improving traffic counting. As you may know, 95% of all traffic counting in New Zealand is done with tube counters. They're fantastic in an urban environment, not so good in unsealed rural roads, and also in some other use cases. So we've developed what we call the network traffic counter. The way how it works is here on the left, you see our camera system either on a power pole, light pole, or in rural environments. We camouflage it in what we call a utility marker. We can detect 14 vehicle classes according to NZTA 2011, and under those are 59 subclasses. And all of these little circles are basically the wheels. So here a 12.3 vehicle is, for example, most of our logging trucks up here in Northland. And a truck can have about 10,000 times the damage of a vehicle to a road. So it's important to understand the weight and the type of vehicles going past. So what we generate is a vehicle by vehicle data capture. So for each vehicle, we do a timestamp, the speed, the class of the vehicle. And what you can see on the top, we're basically tracking then the vehicle through the frame. And after some intrinsic and extrinsic calibration, we can then map the 2D dimensions of a camera to the 3D real world dimensions. So every pixel basically represents a distance. At the bottom, you see one of our trials over, I think, 10 days, where we basically did a time lapse on that road, and it's stuff you won't be able to see on with tube counters. So there's some interesting value of that. Here you can see some of the stations we were measuring last year in Northland, but on the right is a first attempt to show how we can approximate weight transported past that point. So if you want to take traffic counting a little bit further beyond average annual daily counts and vehicle classes, speed and direction, you can estimate the weight. Essentially the way how we're doing it is we use our camera based system and a vibration sensor to work out if the vehicle going past is loaded or empty. So we get the weight out of it. Out of that, we can estimate emissions across that point. Since it's a visual-based system, we also deduct weather information. So if it's light rain, heavy rain, that kind of stuff. We are working on dust detection on unsealed rural roads, which is a big problem here in Northland. The time lapses I talked about. We are thinking of developing real-time road condition monitoring, because our system is working on the edge and we in real time can provide information, for example, if speeds go below a certain point, so that's in traffic jams, crashes. So in comparison to tube counters, which don't work under 30 kilometers an hour, we can work at very slow speeds. We can also potentially detect vehicle industry types, so how many logging trucks, milk trucks have been going past. With the police, we're working on a project to detect work break hours for truck drivers, going over bridges where there's sort of weight restrictions, that kind of stuff. I assume Chris Rapson will talk about sort of their lane 2, lane 3 detection in Auckland. So occupancy rate is something you can use with a camera system, and travel times between multiple points. So to summarize, our transport solutions consist of our fixed location network traffic counter, our mobile crowdsourced solution, our network road inspector, and we have developed a digital twin using a game engine to visualize all this. So I don't want to talk about running out of time in regards to the field days. If you're interested in this, we put together a road traffic management survey, and we've got a demo site, and the slides will be shared. So if people want to learn more about what our system can do, we keen to have a talk with you. So yeah, if you have any questions, will be great. Thank you very much.
Thank you very much, Martin. That was yeah, you did that really quick, covering a lot of territory there. I was interested to see how do you what's the trick, I guess, to integrating all your different sources of data. How are you managing to do that?
Yeah, so we use cloud-based machine learning for this. So we do quite a bit of background analytics, because what we found is it's not about providing more data to the customer and then not providing tools to them. So we try to work the other way around, trying to work out what are challenges and questions traffic planners and road asset managers have, and try to work out how can we provide better tools. So we actually think by combining traffic measurements in, for example, weight and weather information, because sort of a road degrades if you have lots of pressure put on top of the road, and if you have lots of moisture getting into the structure where the road is built on and into the material the road is built with, then you can get sort of issues with it. And we actually think by being smart about collecting these different data sets, at some point we will be able to predict when roads are likely to fail, so that we can move towards a preventative road maintenance regime, so that we're not the ambulance at the bottom of the cliff, so that the road maintenance contractors are not surprised to see potholes. I mean, for example, I live on a quite busy road here, and at the beginning of our road where everyone speeds up, we have lots of potholes, and the roads have just been done maybe 7 months ago. And it's just unbelievable how fast you see the degradation. And we actually think that we can predict when those roads are likely to fail. I mean, we need to do some more research on it. But the idea behind is analytics and customer-driven analytics. So we provide the tools, and I mean, we're not traffic planners or road asset managers, we're IT people. So, but we like to listen to the problems, and it's how we came up with these solutions in the first place. And yeah, I mean, if there are people out there who have specific questions or want to take it deeper, we're very open to have discussions. And since we're not a multinational, we can actually shift focus based on sort of local needs. Thank you.
Fantastic. Thank you very much. Everyone, you've got Martin's contact details there on the screen, and you'll be able to access that from the slideshow afterwards and from the recording when we publish that as well. Thanks very much, Martin. Fascinating to see the work that you're doing up there.
Thank you.
So moving on to our second speaker for this afternoon, Jonathan Stirling, systems engineer from Beca, who is replacing Robert Boucher. But I believe Jonathan was heavily involved in the project that Robert was due to speak on, so he'll be able to, he's been able to pick up the baton, so to speak, very quickly. Jonathan, if you're ready, you can go ahead and share your screen. And you may be on mute. We can see your presentation.
Cool. Sorry, just lost the control for a second. Awesome. Can you hear me now? Just checking.
Yes, absolutely we can. Thank you, Jonathan. Yep.
Awesome. Cool. Well, good afternoon all. As introduced, I'm Jonathan, one of the team from Beca. I'm standing in for Robert, who, as introduced, was going to do this presentation. So today I'm going to just talk through the use of the wrong way driver system that we implemented. It was an initiative started under the Auckland Motorway Alliance, and then further progressed around the Alliance system, sorry, the Auckland System Management Alliance. Oh, sorry, having technology difficulties here.
Is it?
Yep, no, sorry. Yeah, so under Wakakatahi as part of the Road to Zero goal. So to put the issue in context, head-on crashes are most likely to cause injury or death based on the cumulative momentum of both vehicles. So on high volume roads, such as the Auckland motorway network, traffic lanes are divided, being a key prevention. But what happens in the case of a wrong way driver? So to start with, I'll tell you a story about my wife. She was traveling one night with a friend as a passenger and fell asleep. As she woke up, the first thing she saw was two pairs of traffic lights or headlights coming straight towards her. In that kind of wakeness, sleep kind of transition profile, looking up and seeing this, her first reaction was she's about to have a head-on accident and ended up in a screaming panic. Thankfully, they were on a multi-lane road, so everything was fine, but it could have been a whole lot worse. So wrong way drivers can lead to significant or kind of a key cause in a significant crashes, often fairly spectacular crashes, and unfortunately are overrepresented in fatalities. And Auckland is not immune. In Auckland, there's been an average of 1 to 2 people die per year because of wrong way drivers. So this is as serious, and again, because they're head-on collisions, they're overrepresented in serious injuries. And as things evolve, it is increasing. In the US, there's been just over 2,000 deaths because of wrong way drivers between 2015 and 2018, or that's 500 deaths per year. In New Zealand, as I said, it's been predominantly rare, but it has been in crashing with an average of 30, expected average of 30 per year currently, growing to at least 70 fatalities by 2014. Ergo, something needs to be done about this. So the research basically into wrong way drivers, which was undertaken, was first to understand what was the problem. And so we went through and looked at the statistics and trying to work out what was happening. And as you can see there, often a sole driver, often an experienced driver, which is an interesting one, and alcohol and time of day also have a significant impact in the statistics. And this led us down the path of classifying the wrong way driver into 3 distinct categories. The first is unintentional drivers who may be foreign, confused, or simply following a navigation device when it says, take the first exit from the roundabout. The second group was in the impaired drivers. This could be through drugs, alcohol, age, medication, or fatigue. And the third are the deliberate wrong way drivers who, for whatever motivations, have decided that traveling the wrong way down a road is what they're going to do. So once we had an understanding of the types of wrong way drivers, the next step was to investigate the measures that were available to first discourage, second detect, and third reduce the risks from wrong way drivers. Here we focused on entry points to the motorway network that are used by wrong way drivers, being what most of us refer to as the off-ramps, as that is the start of the problem. And if we can address it there, we solve it for the majority of the motorway network. So to discourage wrong way drivers, we looked at physical changes. And so this includes removing of vegetation and extending traffic signals and strengthening road markings to make it obvious to people where they should, or conversely, should not travel. The second set of changes we looked at was changing the lights so that no longer is it a green arrow, a green dot, but a green arrow to provide that further direction to say, this is the correct way to go, and conversely, this is not the correct way to go. Next, to detect and discourage, we trialed a number of radars and systems to detect a wrong way vehicle, and then put in larger warning signs with remote flashes activated so that anyone going the wrong way had the alerting and warning that actually, wrong way, go back. Interesting, with Auckland's motorway has a number of flat-ended vehicles, buses, trucks, and vans, and it actually created a number of radar imperfections or false positive settings. However, in the United States, they actually have these lights on permanently, so anyone will see them, even if you look in your rearview mirror. To detect and reduce the risk, we looked at using induction loops and CCTV and response plans, so that if a driver does cross the wrong way, then the traffic operations centres is notified as fast as possible. Then further able to engage either law enforcement or alert other drivers through the existing VMS infrastructure and that kind of stuff. And this has allowed actions from the traffic operations centres to be reduced from minutes after being notified to mere seconds to engage a plan to appropriately manage any wrong way drivers. So bringing it all together, there is a fair bit of changes that we've done through a number of intersections to try and test the system throughout, and it has been fairly successful. So from 18 prototype sites across the Auckland motorway network, just to cover the different types of traffic, the different off-ramp configurations, and to get a fairly broad view of everything, we expect we could reduce the deaths from wrong way drivers between 50 and 61%. And therefore, if implemented across the entirety of New Zealand, we could look to halve that's estimated 70 fatalities in 2040 to less than 35. However, as technology changes, it's been an interesting study into actually the way that we can detect wrong way drivers and discriminate between direction of travel, multiple directions, reflections off broadsided vehicles as well as looking at the different technologies available. New Zealand is fortunate as we're actually one of the first countries to start experimenting and prototyping with solutions to detect wrong way drivers and the different actions we could have. There are other countries experiencing similar issues, as I alluded to, America, but as well Australia, Japan, and most modern countries have some sort of statistics now showing that wrong way driving is an issue. This is again a key initiative that New Zealand can lead the world again in how we can detect this stuff and also save lives at the same time. So to finish, I'll just ask, are there any questions around this system?
We do have a question from the audience here. It just brought me a flashback. Before I go to that question, it brought me a flashback. I had been living in Finland for about 4 months and came back here and was on a rural road, pulled out of a friend's driveway, and I'd headed off down on the wrong side of the road, and a car came towards me flashing its lights, and I didn't know what was going on. It wasn't until they passed me that it really clicked, and they had to go onto the wrong side of the road to do it. So difficult one. Obviously, I'm not going to be caught by your systems because I'm not going on the motorway. But here's a question. WWD accident savings estimated or actual? That one might have been for Martin. It's just been cleared. That's just been cleared, sorry. That's why I couldn't make sense of it. Where else in New Zealand are you considering to trial it, Jonathan?
So this was all focused at Auckland.
Yep.
Myself and Robert both being Auckland based, as well as Auckland being the largest proportion of motorways systems in New Zealand. We have had discussions around other technologies and other locations, but it was more around proving that actually the ability to detect and the ability to implement an action plan for these. Obviously, the other one, Auckland, has a benefit of it, has the larger traffic operation centres, and obviously, therefore, unfortunately, the largest occurrence of wrong way drivers on the motorways as well.
Yep.
Even in the news earlier, was it Monday? There was for example, a bus going the wrong way down Wellington's motorway networks. So some of the learnings, you'll see the same sign wordings and that kind of stuff has been shared, and the traffic response plans have been propagated throughout the country as well.
Okay.
Just the detection technology hasn't yet.
Excellent. Well, here's a question that goes to that, perhaps, from Karen Phil at Resolve Group. Have you mostly used proven technology, or are there likely to be traffic device rule implications?
So a lot of what we're looking at is proven technology in terms of we tried positional and two-dimensional and three-dimensional Doppler radars, as well as traffic loops. One thing we're very cognizant of is trying to not create too many false positives. And it's a number of systems out there are sitting at the 90 to 95% ability to discriminate a wrong-way driver. However, if you multiply the vehicle movements on Auckland motorways by 5% alone, it would be overwhelming for the traffic operations staff. So it was focusing on that. We did look at trialing various other technologies, but nothing seemed to have that conclusive results. And so ended up with a combination of radar, loops, CCTV camera to allow the operator to verify it as well. And so kind of almost a 3-knock system to prevent that false activations as well.
Cool. So it's a new application for existing technologies, which is an innovation in itself. And it looks like the outcomes that you're hoping to achieve from it would be spectacular anyway. Every life saved and whatever is impressive. So thanks very much, Jonathan. I don't have any more questions from you, I don't believe, or for you, but that was a nice insight into that project. And yeah, great to see that it's been shared throughout the country, even if we haven't got deployments of the technology around it yet.
Cool. Thank you, Simon.
You're welcome. Okay, folks, we are moving on to our third speaker now. Our third speaker is Chris Rapson from Auckland Transport. He'll be talking about their computer vision work. Some exciting stuff going on there. Chris, if you'd like to share your screen.
Yep. Okay, yeah, so yeah, I'll be talking about Auckland Transport's journey with computer vision. And so I was going to be presenting that at the conference together with Derek Zhang. But yeah, now that we're all online and things, it's probably easier if we just keep it to one presenter. Yeah, so I guess, yeah, we'd say the computer vision journey for Auckland Transport, sort of, you could say it started when Auckland Transport was formed, and it sort of inherited, yeah, a whole bunch of different camera systems from all of the regional transport authorities. And then it took a few years for a project to come along that unified all those CCTV platforms. So we're operating off the same sort of baseline. And yeah, this might be a good time to explain sort of, yeah, where cameras come into Auckland Transport operations. Most people probably think of Auckland Transport as operating a network of roads, railway stations, yeah, buses and ferries for public transport, and of course active modes for footpaths and cycle paths. But yeah, a really good way for us to monitor these things and manage them is with cameras and feeds going back to an operations center. So yeah, it was roughly 3,000 cameras yeah, back in 2015, and now it's up around 4,000. And yeah, so the operation system is sort of manually monitoring those things, but yeah, there's also a big advantage if we can automate those things. There's a lot of assets to keep an eye on, and yeah, just a limited number of eyes that can pay attention. So we started out in 2015 looking at a vendor provided computer vision system. It was an offshore vendor. And then in 2016, we brought in some in-house expertise. So that was Derek. Joined Auckland Transport in 2016, and he provided that sort of eyes on the ground for local customizations. And then from there, over the last sort of 5 years, that's mostly what I'll be focusing on here. Been a range of different projects to build on new capabilities that have been coming up in the field of computer vision, and really apply that to a whole bunch of different initiatives. And yeah, over that time as well, the team's grown. It's not just Derek anymore. We've got 8 specialists and a couple of project managers. Yeah, working on whole lot of different projects. I won't have time to go through all of them, but we sort of categorize them into 4 different sort of high level headings. The ones that we heard a few weeks ago from CSLI talking about transit lanes. So that's one that we've worked with them on. But today I'm going to be talking about pedestrians at railway crossings, red light runners, live event occupancy, and stationary vehicles at railway crossings. So yeah, those are just the ones that we picked out. They have a particular safety focus, which is the theme for today. And so computer vision has come a long way over the past decade or so. This is a pretty common benchmark that's used for computer vision. And yeah, I know there are lots of experts in the audience today, so I hope they don't mind me just taking it right back to fairly basic stuff here. But yeah, you can see the progress of computer vision over the last few years. And on this benchmark, it actually starts to beat the human baseline performance around about 2016, 2017. And yeah, these days for this test, it's performing much better than humans. And of course, that's really exciting for us. But there's a little bit of a nuance to it. There are certain problems that computers are really good at. Like if you want to spot these dogs, which ones are dogs, which ones are muffins. This is a pretty tough challenge for humans. You probably have to squint and tilt your head, something like that. It's not something we really do every day, but yeah, a computer can be trained to specialize on this task and then give you really accurate results. Going on about dogs a little bit more, I wonder how well you really know them. So in that ImageNet challenge, there are 120 different breeds of dogs, and you have to get the right breed in order to get the answer marked correctly. And most people aren't going to put in the time to learn their dog breeds. There are a whole bunch in there that I've never heard of. And so that's again where the machine has an advantage on those kind of benchmarks. There are other benchmarks which require a little bit more common sense, and that's where computers still have a little way to go. They're making really good progress, so that's pretty exciting for what's going to come in the future. But they're still not up to human performance, where you need a little bit of common sense, a little bit of experience in the real world to provide useful insights. So yeah, also a little bit of job security for me still there. Cool. So yeah, there's a lot of progress, but take it right back now to something we did several years ago with pretty simple technology. So this just looks at pixels that have changed in the recent past, the last few frames. You can see the lights are flashing, and so that shows up as a change. As people enter the scene and move across, that looks different to the background, and so we can spot them. And as the people move through this danger zone while the lights are flashing, then we can raise an alert. So yeah, that works quite nicely. It gets a little bit difficult when 2 people are walking beside each other and then these clouds of pixels sort of merge, and we can't really tell if it's 1 person or 2 people or something like that anymore. So yeah, definitely has its limitations, but for this application, gave us quite nice results. We implemented it at a whole lot of different railway crossings around Auckland. Then we could collect statistics. We can see that, on this particular place, people are moving west in the morning and east in the evening. So obviously going to work or to school and then coming back. And we could also export those videos for manual evaluation of the demographics. And so we had roughly about 700 examples of people crossing the tracks when they shouldn't have been. And we can look at that and see that where we might have thought that sort of the younger people would be more reckless and risk-taking. There were some, but actually the majority were adults who you might have thought would be more responsible. So yeah, that was one of the big insights. The other one was we thought people might have been distracted, listening to music, or the classic looking straight at their phone and not noticing what's going on around them. And while these numbers are worrying for sure, they're not actually a large fraction of the people who are putting themselves in danger. So yeah, this is data that really gives us an insight, and it's became the center of a targeted campaign to raise awareness and hopefully bring those numbers down. We also implemented some technology to detect red light runners. So the traffic light is directly wired into the camera, and when it's red, it comes up with a little red square here. And then while that red square is up, we can detect if a car moves into the intersection. So the square is for right turners. We can see it moving into the intersection from this direction, and then it will exit the intersection, making a turn. And then we can, again, pick up an alert and collect some statistics on that. So yeah, Auckland Transport doesn't enforce red light runners. We leave that to the police. But if we notice really bad statistics at a specific intersection, then we can tell the police to target that intersection, perhaps at a specific time of day, different days of the week. Or we can look at redesigning intersections. So perhaps the layout or the phasing needs to be changed to improve safety there. This was perhaps one of the biggest breakthroughs in computer vision technology the last few years. So now we're not looking just at pixels, looking at the individual objects, and now it's not such a big problem that the dog is in front of the bicycle. But this is a really, really famous, probably the most famous computer vision image around. And yeah, it comes from, you can download it and use it straight out of the box to detect various classes of objects. It doesn't actually have out of the box the classes that we need. We're not so interested as Auckland Transport in the bicycle. We're interested in the unit of bicycle and a rider. So that becomes a cyclist, or if it's a motorbike, it becomes a motorcyclist, or something that we call a scooterist. All of these things that don't really exist in the generic out of the box solutions. Our cameras also don't really take this image, which is kind of close up to the object and straight on. We more sort of look down onto a road. And so we've had to manually label thousands of these images from this view angle and for the types of objects that we're interested in. But now we've got a really nice solution to detect those objects to provide really, really solid for a whole range of applications, gives us really solid detections. One of those applications was the America's Cup Village earlier on this year. So yeah, the organizers of the America's Cup wanted to basically know how many people were going to be in this yellow area when the racing was on, when all the people came down for the public viewing, watching the big screen. It was obviously a massively popular event. And so we set up cameras at various entry points, and we counted how many people were moving past the camera, going in, coming out. And sort of, if you count how many people go in, how many people come out, you basically know how many people, what the occupancy is. So yeah, even though there's a pretty big crowd of people coming past the camera here, we can more or less keep track of every single one. We can see cyclists, we can see people. In this case, we were pretty agnostic to the mode of transport. It was just the number of people that we were interested in. But that capability is there. So yeah, I hope everyone's keeping track here. There'll be a prize at the end if you get it right for how many people are moving past. Cool. And yeah, that goes into a dashboard where this was, so they could have live information on how many people had come into the area throughout the day. We've got and they also have historical information of the past 30 days. So this was during the Prada Cup. When the racing was on during the weekends, we had really big crowds coming in. And then after the racing finished, it dropped down to sort of the normal weekend traffic. And then they've got information here on individual cameras, whether there were any technical issues. And they could apply all that information to manage their event and improve the safety. All right, so coming back to railway crossings for the final example. Again, we're looking at these, the vehicles are being tracked with boxes, so all of these overlaps are not a problem. It also gives us a much better handle on how fast an object is moving. And so if we know the velocity, we can detect when it's stopped. And so this is stopped for 5 seconds, or yeah, some number of seconds within this yellow hatched zone, and then after a while we can raise this warning and detect when somebody's potentially in the way of a train. And yeah, again, we're keeping statistics on that. We can detect the type of vehicle that's doing that and the time of day. So afternoon seems to be a much bigger problem than during the morning for this site. And yeah, the overwhelming majority are cars, but of course also from an Auckland Transport perspective, there's a worrying number of buses there that we might need to look out for. All right, so yeah, that's all that I've got today. Just a quick overview of 4 different projects where we apply computer vision to improve safety. And yeah, thank you for your attention. Stay safe.
That's awesome, Chris. Thank you very much. Yeah, and just those are just 4 examples, and you had a huge list there, which I didn't quite grab all the examples of the applications you're using there.
Yeah.
Very impressive, and yeah, just I guess obviously adding to what CSLI talked to us about a month ago. So you guys obviously not doing the enforcement, but how are the police receiving that data? I mean, it looks pretty good on the dashboard there. Are you what's the questions coming from them, I guess, as the users or the clients, and if you want to look at it that way?
Yeah, so like I mentioned, the locations where we have particularly high numbers of red light runners, and the times of day, and then pretty much all they have to do is put a patrol car there, and the rates of red light runners go way down. So
cool. Do you foresee a time when it becomes more active than that, where you like just taking that last example, you had cars in that crosshatched train crossing. If we think about Auckland and the frequency of trains going to be picking up perhaps on the Western Line, is that something that's going to be perhaps integrated at some point and automated?
Yeah, so there are a few applications where we directly send an alert to the operating center, and then they can verify that on the live feed, and then they can get in touch with police or somebody else to take an immediate action. And so
cool.
Yeah.
Oh, excellent. Okay. And maybe I guess where I was getting to was there is going to be perhaps a next step to that again, is that it doesn't need that human factor in there anymore.
Yeah, we that's definitely our long-term goal, is to automate as much as possible. Yeah, we are, as the earlier speaker said, also really wary about high levels of reliability and false positives. And yeah, that happens when most people are doing the right thing. Sure. False positives are really a challenge.
Cool. I got one more question here from Doug Wilson in the audience. He asks the age-old question which comes up when you're talking about CCTV, which is in regards to privacy and face and person recognition.
Yep. So yeah, Auckland Transport takes that really seriously. We have a blanket policy to not do any facial recognition. We're interested in how people move and sort of the statistics of who goes where, what times of day, that kind of thing, and we don't really need to know which individual person is doing that. And the only exception to that, the only permission we have to take any kind of personalizable information at all, is to enforce bus lanes, special vehicle lanes. So at that point, you need the license plate of a vehicle in order to carry out the enforcement. So that's the only identifiable information that Auckland Transport collects through the cameras.
Excellent. Thank you very much, Chris. I think that's all the questions we've got time for today. Need to keep things moving. We've got more speakers to get to, but that's a brilliant insight, and I look forward to hearing more from you guys in the near future.
No worries. Thank you.
Cool. We're going to move on now to Andrew Gurr, who has joined us. And Andrew is the CEO of Fusion Networks and is going to be talking about the automation of multiple systems. Andrew, if you can share your screen there, you should be able to do so automatically.
All right, let's try this. That one.
Great.
That work?
That works for me.
Cool. All right.
Take it away.
It flows on quite well from Chris in terms of talking about automating, but this is the operational end of the technology that supports all of the camera streams and other things. This was a presentation I was due to give in July. Ironically, the ITS conference was cancelled because of the lockdown in Wellington because of the COVID case. I was also in Wellington on August the 18th when the community case in Auckland resulted in the next lockdown. So I've decided I'm not going to Wellington till after Christmas, so you're all safe. This is a little old because this project also got stalled slightly in terms of progressing from COVID, but talks through our direction in terms of trying to automate multiple systems by another system. Let me just get through to the next slide, which is not going. Try that one. There we go. So big challenge all companies have with lots of overlaid technology is they're frequently siloed, and to support them means you end up with different people logging into different systems to try and manage all of those as a whole, and that takes increasing amount of human intervention, particularly triaging. Auckland Transport have many thousands of cameras, VMS signs, all sorts of things around, and so do all the other councils. And normally it's a combination of internal teams, contractors, etc. And this project here is about trying to remove the manual components by linking together systems that normally wouldn't get linked together, and technologies allowed that to happen, like AI's allowed the intelligent processing of data from the cameras to do the clever things Chris was talking about. The APIs have allowed software to talk to multiple systems and essentially to run them as code, as the catchphrase, if you like, where you can have a central repository where you're kind of managing lots of data sources in one place. So we've turned our attention in this regard to an operating problem, which actually started with SCATs, managing traffic lights. So this is just a common string of manual activities for a complicated fault, where it could be power, it could be checking if the network's up, logging into one system to create a ticket, talking to a contractor to go to site, coming back to Fusion to check if the network's an issue, going backs and forwards to different people. And if it's a complicated problem, it could involve going to site. And so this sequence here can take weeks and many, even up to hundreds of hours of people time, and that problem gets repeated on frequency, and it depends, I guess, how often those problems come up. Shorter problems can happen very regularly, and essentially we end up with a team of people talking to each other, often via email, just to try and resolve some of these problems. So we thought about using a software tool that we've deployed as part of the suite of tools that we use out of US called Untitled. And that's essentially an API tool which allows us to connect to multiple different systems right at the heart of those systems, pull data out of them, and build custom workflows around that data we're collecting to enable us to do the triage work that we talked about, showed you on the last slide, but do it automatically and go and give some intelligent information to a contractor rather than doing it manually. So where we got to, and we were going to present this back in July, is a proof of concept, which is still a proof of concept at the moment. And this is an example of a workflow which is talking to 8 different systems and about 1,000 network devices. And inside this one particular process is a whole lot of nested processes, and depending on what data is found, it will enact a different activity to collect that information, and this is running essentially multiple times a day, so it's reaching out at around about 4,000 ITS devices. So the first stage of this project, I'm just going to show you a quick demo while I talk. Hopefully that's going to start. So this is the portal we put together which is showing the data that we've been collecting. Essentially, it was going off and collecting information from those multiple sources, and these are all being presented here. I don't have time to go into all exact detail around it, but it provides a level of visibility from multiple places in one front end, which normally the operators would have to go either they wouldn't have access to because they don't have access to those systems, or they'd ask somebody else to go and do it. And this essentially is pulling that into one place. The next stage of this project, which is still being reviewed, is to integrate it into the different operational tools and also some other systems which we currently don't have access to. And I think we've got that here, which included ServiceNow, RAM, the actual SCAT application itself, Altima, which is part of the communications network, and interestingly enough, Chorus, who have what's called a last gasp power data that they get out of their ONTs throughout the country. So we'll be able to tell when power is out in a certain region, which is often the root cause of things going offline. So once these 5 systems are overlaid across that data we've already shown, we can start actually doing the correct triage and issuing support tickets to the right person with the background of everything that we know is either working or not working, and prevent them having to go and find that. And essentially we can take that 2-week workflow I showed at the beginning down to possibly even seconds, which is particularly significant collapsing of time. And once that's established, then those processes can be applied to multiple different problems that are similar. And I'm going to skip that because that'll be hard to see. And that's it.
Thanks, Andrew. Nice and concise. It's I guess the question I was trying to understand as you went through there was: are you looking at the device health, or are you is it more like a technology asset management, or is it actual operational defects far beyond that as well?
Let me go back to that slide. So it's the whole train. So essentially having an API tool in the middle of all of these systems means if we can collect information from any system, it can be applied to operators, for the contractors, for any of the providers in that string, from the software application all the way through to the ITS each device. So it's the entire sequence and could be used to improve that process for anybody in between in any of that technology string. It's not just the network. We're kind of using the network to look out, but that's only for the proof of concepts. The intention is to link directly into all of those systems themselves.
Cool. Yeah, it does. It does. And correct me if I'm wrong, this is something that you weren't necessarily being asked to do, but you saw the potential to do it through the system that you had.
Correct. So we brought Potential on for our own operational activities, and we pointed it essentially starting to point it at any manual activity that could be automated. But in doing so, we also looked at all of the requests coming into Fusion in terms of connectivity. So being able to not just respond to connectivity issues, but actually digging deeper and going, well, actually, we think the problem is here, and then sending it to the right person. That's just a logical step. So,
yeah.
so yes. So we have we've built a slightly different version of this for a different government agency, which has gone into production, and that's certainly been quite valuable. So using the, I guess, customers using the data as much as us using it for ourselves. So it's anywhere around those operational improvements when you manage lots of technology.
Yeah. Yep, fascinating. Sorry, I've got, there you go, the alarm's gone off, so that says your time is up, Andrew. Really appreciate you being able to join us and share that with us. It would be, yeah, it would be worth digging into that a little bit more and hearing perhaps what you've done with your other government clients as well. Thanks very much, Andrew. We'll keep things moving and moving along to Ayesha from Beca. And well done. Thank you very much. She's sharing her screen there, so she's ready to go. That's excellent. Take it away. You may be on mute.
Cool, I just got that now. Awesome, thank you. Kia ora koutou katoa, ko Ayesha toku ingoa. Welcome everyone, my name is Ayesha and I'm really happy to be sharing this afternoon with you. So I'm a transport engineer at Beca, and over the past 3 years, I've been involved in a number of research, design and transport planning projects, and I've been given the space to really try bring a sustainable and an equity lens into each project that I get involved in. And I'm pretty grateful to be living in the era we're in now, to be able to see new technology come through the door, such as autonomous shuttles and autonomous vehicles, and be able to envision the potential to create sustainable and equitable transport solutions using technology. But it's not always easy or a straightforward task, and it can be difficult to understand how the benefits of different emerging technology and innovations can be fully realized and shared across society. So over the next 10 minutes or so, why don't we explore the aspects of a future smart city such as autonomous shuttles and understand their impact on communities using an equity lens. Cool, so Aotearoa's Land Transport Government Policy Statement outlines 5 transport outcomes, and this is in the form of a framework. So transport planning in Aotearoa is essentially aimed at achieving these outcomes, and one of the 5 outcomes focuses on inclusive access. So this outcome sets a priority to enable all people to participate in society through access to social and economic opportunities. And this framework shows that transport itself is not the end goal, but more an enabler in providing opportunities and improving well-being and livability for communities. So beside these 5 transport outcomes, I think it's also really key to bring in the cultural lens. So Te Ao Māori, which is the Māori worldview, integrated into the emergence of new technology, can basically provide broader benefits. So we can get so used to having a narrow view and solely focusing on one key outcome. However, Te Ao Māori allows us to use a holistic approach and acknowledge a broader range of outcomes and essentially help us to prepare for a technological change. And I think developing our cultural competency around Te Ao Māori helps us explore the values which enhance our wisdom to the question of technology. And in New Zealand, we do have a unique opportunity to combine Te Ao Māori and the Western view, which will result in outcomes that are distinctly designed for Aotearoa. So this is still an area where I am learning a lot, and I'm always looking for ways to incorporate Te Ao Māori into my everyday projects. And I came by this whakatauki, which is a Māori proverb, he waka eke noa. So this speaks to working in unity and leaving no one behind. And this essentially resonates with the idea behind equity. So now, before we delve into the world of autonomous shuttles, it's really important to first understand equity and how it's different to equality. So I quite like this graphic. So it clearly highlights that difference between equality and equity. So the image on the top shows the same bike being provided to people with different abilities. So equality acknowledges and provides the same service or technology to everyone and assumes that everyone receives the same benefits. The image below shows different bikes being provided to the individuals to suit their specific needs. So equity acknowledges that people come from different backgrounds, have different circumstances, and essentially have different needs. So yeah, equality is giving everyone a bike and equity is giving everyone a bike that fits. So there's many measures that can be used to evaluate the impact of transport on social equity, and cost is one indicator. So low-income families are affected by transport costs as they may spend a large proportion of their income on transport alone. And this further limits the access to employment, education, and limits families from participating in society. And families may also live in rural areas as it's cheaper. However, it doesn't necessarily, these areas may not necessarily have well-serviced public transport. The second barrier is that mobility groups and visually impaired and elderly cannot easily or safely access the transport network. And this brings feelings of frustration and anxiety to these groups as it makes it difficult for them to become independent. And another one is that certain communities could also suffer the worst health impacts from the transport network, the transport system, as they may be exposed to high levels of air pollution or a greater number of injuries and deaths from road crashes. So with this understanding, we can begin to ask the right questions for when we look to deploy new technology. For example, what would be the impacts on transportation costs for low-income households? Or what is the impact for access to jobs, education, and healthcare for a particular mobility group? And we could also ask, what are the likely health outcomes on communities? So we're starting to see that autonomous forms of mobility could have a profound impact on society. And it's exciting to see autonomous vehicles being introduced across the globe in many shapes and forms, such as autonomous shuttles, minibuses, and even autonomous pods. It's also exciting to see many trials happening, and these trials are a great way to hear feedback from the public and basically understand any barriers and the experiences with new technology. So strong engagement with communities can be part of the planning process to make sure these solutions are tailored to the community's needs. So here we have a few autonomous shuttle trials from different parts of the world. We can see a wide range of use cases. So there was a trial carried out in Switzerland where shuttles served streets that were not easily accessible by typical buses. Another trial was carried out by Omeo, providing access around Christchurch Airport. And we can even see trials happening at universities, such as at the University of Minnesota. Other trials show autonomous shuttles being able to connect neighborhoods to nearby rail stations or retail centers. So there's definitely aspects of autonomous public transport services that can form a wide variety of use cases. For example, we can consider whether the service should be an on-demand or a scheduled service, or whether the technology could serve as a first last mile connection or a feeder service, or even a mainline trunk service. So there's been a few trials that's also been carried out in retirement villages. So a trial was carried out in Port Elliot, Southern Australia, and this received very positive feedback. So autonomous shuttles were seen to enhance social interaction for the residents. Many of the trials show that vehicle manufacturers also considered wheelchair users and prams as they designed vehicles with built-in ramps and large doors. So that's really great to see. And yeah, so we can kind of see that a future with autonomous shuttles and buses holds many promises and could deliver great environmental and social benefits. And through this transition, it is important to hold an intentional focus on equity to make sure this technology can improve the lives of those who need it the most. So how can we apply an equity lens to emerging technology? So Beca are creating a framework to maximize our positive social impact in our projects. This framework will trigger questions such as who are we designing for and are we improving universal access for everyone? It addresses issues from an income and social class standpoint, as well as addressing mobility needs and geographies. So currently we're just using this framework on various projects, but there is the potential to create something similar or a similar tool to assess emerging technology. And this framework could basically help to weigh up the potential benefits of emerging technology, and also just to first help identify existing gaps in the transport system. And then from there, we can establish objectives or transport needs for a community. To show how the framework can identify opportunities, we could use an example. So let's say we have the objective of deploying autonomous shuttles to serve as a first last mile connection between a neighborhood and a public transport hub. We could ask whether we are considering the needs of those that potentially work late shifts and whether the service can provide a connection for this group, as they may feel unsafe and uncomfortable walking, let's say 600 meters from the PT hub into the neighborhood streets that may not be well lit. So this could really make us question whether we are providing the right type of service, and perhaps even something like an on-demand service could help to cater for those needs. So it's about adopting that thinking and using the framework to help identify ways to improve equity and understand whether the technology is right for the community. So this slide shows a selection of potential framework outcomes, and with clear equity outcomes in mind like these, we can start to understand the full impact of emerging technology to make sure no one is left behind. Technology can be key to addressing transport inequities and empowering local communities. So we need to make sure we are asking the right questions and start reframing the question from how can we use this technology to what do our communities need and how can this technology help give them that? Thank you. Do we have any questions?
We do have a question that's just come into the chat actually, rather than the Q&A. Oh, sorry, maybe. So I've got two questions, I think, actually. So let's go to the first one that I saw, which was actually from Helen Fitt, your fellow panelist today. Does your work include reflections on the way that transport technologies influence urban form in the longer term?
I think there definitely is a correlation between the two. So obviously land use integration has a huge impact on equity and outcomes around equity in the future. As you know, we need to make sure that we are providing access. So I think in terms of like the framework, we don't necessarily have a specific question around land use integration, but I think that all definitely is linked, and it's definitely something that's in mind in terms of the question of equity.
I guess it's pertinent because I guess autonomous shuttles are seen as a solution, in particular when maybe cars are being discouraged. So you're introducing a technology solution or a new mode to overcome the equity that might be removed when you do that, or reduced. It's an interesting one. The other question that came in from a technical perspective, how feasible is it to implement the public transport system in Auckland, and what sort of benefits could be expected? I guess this is into autonomous shuttles. How long will the transition period be for Auckland?
So I think is that maybe potentially around trials, and if that was to happen in Auckland, I assume the question's around that. So I think there would obviously be a lot of work and planning that needs to go into that process, and understanding, especially with a lot of trials that are happening at first. And I think a lot of community engagement will need to occur in that planning process to make sure that this is the right solution for the community, and just seeing what the public actually thinks of the trials. And obviously there would need to be a lot of influence and emphasis on the safety side of things. So just having those trials that go out and just
Mhm.
ensuring that we do have public trust and
Mhm.
there's not necessarily an overconfidence in the technology itself. So yeah, not necessarily sure on the exact steps that would happen in terms of that planning process, but yeah, I think there would be a lot involved. But it's a really good question. Yeah.
Good answer to understanding that that's not really the the critical focus of your presentation. One final question here quickly from Karen Fell at Resolve Group again. What response are you having from clients to applying the equity lens across your projects? Have you got some responses from clients to that yet? Is everyone supportive? Are there any perceived downsides?
Yeah, so the framework is currently in a bit of like a trialing process. So we're kind of using it internally within our own projects. And I think it's more of a conversation starter. And we're really, it's just making us really ask ourselves those questions and make sure we are asking the right questions. But I think definitely when we have those discussions with our clients, we have points that we can bring up. And I think the end goal would be to actually bring this out and share this work with clients and see what their thoughts are and see if they're supportive. So I think that's probably like the end goal and definitely what we're working and striving towards.
Cool. Okay. So one final question from me then. On the flip side of that, who are you getting your inputs from I guess the users that are commonly affected by equity issues?
So with the inputs, I think, so currently while we're trialing this framework, we're kind of using the transport outcomes framework as well as a bit of a basis, but going into the different aspects in terms of transport indicators. So thinking about gender inequities, potentially different mobility groups. So we are asking those questions. And I think the next step would actually be to get those inputs from the wider network as well, just to understand what people's perceptions are, and just definitely having those open conversations to see what different people, the perspectives of different people are and the barriers that people face, because those barriers that people face are very different between us, and we all face different barriers within our transport system or our network. And I think it's just definitely happening those open discussions to see those different sides and those different perceptions. So yeah, it's kind of a hard one to answer, but I think it's like an ongoing process where we're just trying to get those inputs and learn as we go.
Absolutely. Being open to further critique is good. Fantastic. Thank you very much. And I love to see how it's kind of being applied to technology as well, rather than, I guess, urban form is the key one where people tend to look at it as well in terms of accessibility. Thank you so much, Ayesha. That's wonderful. That's all the questions we've got time for you. So I shall move on to our next presenter, who is Helen Fitt. Helen's there.
I'm here.
Yep.
I am just stopping you from sharing your screen. Brilliant. Have you got mine?
Not yet. Here it is.
Okay, fabulous.
Thank you.
Janet, a female electric vehicle owner and research participant, recently told me, when I have gone into one of the EV places in town, I've not been greeted as one would greet a customer, but felt rather more like a stray cat that the salesperson was surprised to find wandering into their showroom. Janet also talked about being ignored or shut down at trade shows, at service locations, and even when trying to order parts over the phone. She's not alone. In a recent research project, I was asking some New Zealand EV drivers about issues associated with gender, amongst other topics. Now, I'm happy to talk about methods and literature and background rationale when we come to the questions, if anyone would like me to, but I haven't got very long. So I'd like to focus mostly on the results. And I want to focus on 4 topics. First, the opacity of gender dynamics. Second, car purchases as a male domain. Third, technical competence. And 4th, driving competence. Now, there is much, much more that I could talk about from this research. So do please feel free to save up your questions for me for the end. And I've also got a report on the use of EVs in tourism coming out next week. So if you want that, get in touch and I can send you a copy. But these 4 topics give us a starting point on EVs and gender. I want to start then with opacity. Sometimes inequality is almost see-through when we're not actually looking for it. John, one of my research participants, told me, from my observations over the last 5 years of EV ownership and getting out there and talking to thousands of people, there is absolutely no gender difference at all. I've heard many men say to me during park-up events that they're going to buy an EV for their wife. I've often bumped into them a few months down the track, and many times have been told that their wife loved it so much, and they themselves loved it so much, that they went and got a second EV. Now, John clearly didn't interpret his experiences as demonstrative of gender differences. To me, though, given everything that I've read on the topic and everything that I've heard from participants, the idea of men buying EVs for their wives is in itself a gender dynamic. I'm not necessarily saying it's bad, but if it's an observation about a systematic difference between men and women, then it's a gender dynamic, as is an apparent initial perception by the men that John describes that EVs may be more suitable for women than for men. I think the main point here is that it's easy to look straight through what we're used to seeing, and an initial impression that things aren't gendered or racist or ageist or based on any other type of stereotype or prejudice might not actually be the full picture. So I want to look then at some of the gendered dynamics that participants did describe. And here we come on to the idea of car purchases as a male domain. Like Janet, who felt treated like a stray cat, other women told me that sales staff at car yards and garages ignored them, and some noted that even their own family members didn't take their opinions on cars very seriously. Harriet told me that the only time she'd been able to express her views on cars with her husband was when they were buying her current EV, because they were both learning. When I asked Harriet if her husband would now buy an EV himself, and if he'd seek her advice as the household's main EV driver to date, she replied, yes, he would be keen to buy another, but no, I don't think he would listen to input from me. Now, of course, this isn't the case for all women. Some do take the lead on car purchases and some have an equal input. But most women reported at least some negative experiences in this domain, and men generally didn't. So car purchases were commonly described as a male domain, in which women have more limited agency or ability to act, are less likely to be listened to, and are less likely to be treated as serious and knowledgeable customers. Now, of course, the way that we understand our own and other people's competence can vary in different domains. So I also asked men and women about their perceptions of their own competence and confidence in a range of different car-related fields. I don't have time to cover everything, but I do want to touch on 2 topics: technical competence and driving confidence. So first then, technical competence. In general, men reported being more knowledgeable about cars than women and more willing to have a go at car maintenance. Now, not all men describe themselves as technically proficient, and not all women describe themselves as unskilled in this area. But there was a clear spectrum, with men clustered more towards the skilled side and women towards the unskilled side. Now, I really hope that we are past the days of thinking that women might just not be interested in technical subjects, or even worse, that they might not be capable of understanding. But there is clearly a difference here. And so I think it's worth acknowledging it and talking about it. When I asked participants why they thought this difference exists, the answer was pretty uniform. Women just aren't included in the kinds of situations and conversations where they learn about relevant topics. Elizabeth noted, now that you've made me consider these questions, I would say that I rarely talk about cars with women friends and learnt more over the years from male friends. Now, this isn't exactly a revolutionary finding, but one of the interesting points that participants raised subsequently was the potential for EVs to become an equalizing technology, because most men don't know much about them yet. So women have a bit of potential for a head start. So we'll come back at the end to how we could potentially use this to generate a more gender equal playing field around EV conversations. But first, I just want to touch on driving itself. Almost all of the male participants in the study reported feeling that they were good and confident drivers. Several referred to the infamous perception that most drivers think they are above average, otherwise known as the phenomenon of illusory superiority. For example, David cheerily reported, yes, like most people, I am an above average driver. Now, none of the women actually reported thinking they were a bad driver, but almost half of the women who commented on their driving ability included a caveat about something that they weren't good at, whether it was reversing trailers, driving at night, occasionally losing focus. Men just said, I'm good. Women said, I'm good, but. Now, there's a body of literature, the stereotype threat literature, that demonstrates that when we tell people that they're unlikely to be good at something because of their gender or their race or their age, their performance in it is compromised. I'm happy to try to answer questions later about how that actually works, but for now, I'll just note an excellent Australian paper that demonstrated that just reminding women of the stereotype that women are bad drivers made them twice as likely in a simulation exercise to run over a group of jaywalking pedestrians. So the question I was asking myself is, do women add these buts? I'm good, but, because they're repeatedly told by stereotypes and the people around them that they're bad drivers. To start out testing this, and it's not a full test of this idea, but it's a starting point, I asked men and women 2 questions. First, do other members of your household critique your driving? And second, do you critique the driving of other members of your household? Broadly, the men, when asked if other members of the household critique their driving, said no. And when asked if they critique the driving of other members of their household, they said, I try not to. The women, in general, said, when asked, do you critique the driving of other members of your household, said no. And when asked if other members of the household critique your driving, honestly, more commonly than it's comfortable to hear, reported things like, it's so bad, I've stopped driving when there's anyone else in the car. Now, that might sound like I'm having a bit of a go at male drivers and being a bit unfair, but let's let Michael explain his family's driving dynamics in his own words. So I asked, do other members of your household backseat drive or critique your driving? He said, no, my partner normally goes to sleep. I asked, do you critique the driving of other members of your household? And he replied, I must confess to being a bad passenger. Naomi, my partner, sometimes tells me that there's not a brake pedal in the passenger well. I've replied that I was just wondering why we were still accelerating when I could see that the next traffic light had turned red. These days, she just gets in the passenger seat. Perhaps the most worrying thing about this is that if we accept the findings from stereotype threat literature, each time Michael comments on Naomi's driving, even if he's trying to offer helpful tips to make her life easier and safer, she probably actually becomes a worse driver, putting both of them and others at higher risk. So this is a complex combination of issues associated with gender and driving. If we want to make driving, and particularly EV driving, more equitable, what to do? Well, I'm almost out of time, so I'm going to keep this very quick. The opacity of gender dynamics. Well, let's actually look for instances of gendering and other disadvantage. When we look, we are much more likely to find them and to be able to start thinking about how to fix them if that's what we want to do. Car purchases as a male domain. Let's invite women in. Let's train sales staff to see women as legitimate customers, which they are. And let's all commit to asking our female colleagues or wives or daughters or mothers what new car they think we should buy. Even if a particular woman is not interested at all and doesn't care and doesn't answer our question, perhaps because historically she's been told it's not her place to, we'll be breaking down that pervasive idea, one little question at a time, that her opinion isn't valid. Technical competence. I think there's real scope here to encourage women to understand how EVs work. I suspect there may be a time-limited opportunity, while the perception remains, at least for some people, that EVs are most suitable for women, to encourage women to learn how to talk about EVs and to own this space. While women and men are on a similar footing exploring household EV purchases for the first time, let's target some of our information specifically at women and make them feel that they are able to understand this information and to become the knowledgeable car purchasers and owners they have the potential to be. And finally, driving confidence. Let's stop criticizing women's driving. Just stop. Doesn't matter whether you're male or female or neither or both or however you identify, just stop. Don't try not to criticize, stop. It'll make the women in all of our lives happier, and it will make all of us, both inside the car and outside, safer. Now, obviously, this has been a pretty quick run through on some of these ideas. There is much more that I could talk about, and we could go into all the complexities and nuances that make this topic area less black and white, less male versus female than I've had time to represent today. We could talk about the women who are very competent and confident, and about the men who unswervingly reject any assertion that women are less competent and that cars are a male domain. But for now, maybe we could all start with trying to make Janet feel just a little bit less like a stray cat. Thank you.
That was great, Helen. Really enjoyed it.
Thank you.
Did you, because you're obviously studying other aspects of EVs as well, is there other areas where you thought the gender issue kind of impacted on, you know, like if you're looking at tourism and EVs, is it, you know, do women rent EVs as much as male men, or is that, you know, is that, I guess, are you seeing anything else that's interesting beyond just the purchasing and the driving?
From a gender perspective, I would say we haven't got anything that's really systematic enough to report on. We were going to start out this project. I actually did my first interview on this project in March 2020. And we were looking at how international visitors coming into the country might rent EVs and use them on rental holidays. Approximately 3 days later, we went into level 4, and several of the companies that I had interviews lined up with went bust. So we did hit that part of the project on the head. So I've been talking to EV owners. I suspect there may be something in there about the kinds of EVs that people drive and also the way they drive. We have got some interesting findings on the potential impact of EVs on the holiday road toll. And I have a suspicion that there may be a gender element to that. But we're probably a little bit early to say that. I can talk more about that if you want me to, but if you've got other questions, then I'm happy to stop there.
Okay, I've just got a comment come in actually that you should contact a woman, I presume, Alina Dini, from a company called Whirl in Australia.
Okay.
Yeah, similar kind of threads, it sounds like. That's from Michael Roth at Auckland Council, and I can put you in touch afterwards, Helen, if you'd like.
Excellent, thank you. I will look that up.
Cool. Do you, I guess, did you also think, knowing that you've also researched other mobility forms as well, do you think they would translate into, say, let's say, e-bikes or scooters or you know, the level of comfort with autonomous shuttles, for instance?
I mean, I think there probably are differences in a variety of different realms. We have done some work looking at e-scooters and at e-bikes, and there is some potential that e-bikes actually may be less gendered, particularly for young people, than e-bikes. Cycling has quite a strong gendered element to it. So I think so. In terms of the shuttles, I mean, it's a really interesting one. Again, I guess it to some extent, it comes down to how ITS as an industry engages with diverse populations, because most people of whatever gender will not yet have experienced an autonomous shuttle. And as we go forward, if the opportunities to discuss them and to talk about them and to experience them are gendered, then the perceptions are likely to evolve in a more gendered way. So I think as an industry, we probably have a responsibility to try to make sure that happens as little as possible.
Absolutely. Great point. That is all we have time for, Helen. Thank you very much. Fascinating presentation. Thanks for your time. That's great. It looks like Steve and Kirill have already shared their slide, so they are ready to go. Perhaps they'd like to unmute themselves. I think Steve, Griffith, and Kirill Yushenko from Resolve Group.
Right. Thank you, Simon. So you've actually already done the introduction, so thanks for doing that on our behalf. And before we start, actually just wanted to acknowledge the last presentation, actually the gender inequality piece, that inequity piece that Helen raised, and that we did consider that aspect in our work, but it didn't intersect it based on the direction we took, but we acknowledge it's actually quite complementary to that, so thanks for that. And also the presentation prior to that by Ayesha, there was quite a useful intersection with inclusive access, which we think speaks quite strongly to some of the themes that we'll raise here. So it's good to see the number of us are on the same page. So our presentation today is about achieving social equity through the smart application of technology, because while we consider there's been a lot of good achievements in transport information, and that largely centres around safety, operational efficiency, and also outcomes associated with the reliability of travel information. However, we do accept that there are many challenges associated with sharing information equitably, and Kirill and I have actually done a desktop study to look at some pieces of information from New Zealand and elsewhere and around the world, and we've broken it into a number of key three themes. So this presentation will explore these themes and also propose some future next steps.
Thanks, Steve. I would like to explain the diagram, which is pretty much the simple example of some of the today's user interactions with information and communication technologies, which actually plays a fundamental role for the people to be able to interact in a digital world. It's very difficult to imagine the following areas like education, recreational, social, work, health, and of course, transport without ICT. This is fundamental, really. So increasing and improving quality of user access to ICT is a starting point in improving information equality. Multiple studies we've seen show that rapid development and spread of ICT in certain countries, including availability of internet and fast access to the required information and services, have led to improved well-being, life satisfaction, life expectancy, and definitely helping economic growth of the countries, and not to mention, of course, environmental sustainability. Well, Steve will go into details and explain the level of access of ICT domestically and internationally.
Thanks, Kirill. So, yeah, I think based on Kirill's explanation and the transport-related theme, there are digitally excluded people in New Zealand, and given that it's the 21st century, we feel that there's a number of different there's a number of shortcomings we feel can be addressed. You know, it's quite a challenge in that there's quite a significant number of groups with reduced access to resources such as the internet, and therefore to critical information services and other things that really enable us to live our day-to-day lives. And this has a adverse effect on people living with disabilities, people living in social housing, people also living in remote and rural areas, and those aged, elderly people, for example, those aged over 75, and also the unemployed. But there's three key topics which we're talking to, and the first one is related to cost. So the diagram you can see here is a snapshot of some of the more common forms of information sharing that we use. Broadband affordability and mobile fixed broadband penetration. So you can see that affordability and information coverage, particularly in New Zealand, it's generally pretty good compared to many other countries throughout the world. However, with a relatively low population size and density, it is as it is in some other countries. It's unevenly distributed, particularly on a geographic basis, but also on a socio-economic basis. The diagram there just shows Spark, New Zealand's latest 4G coverage across the country. That coverage doesn't necessarily reach some of our more rural communities, and while a large percentage of us live in urban areas, it is important for the sake of equity and also equality to be able to access those people and to provide the information they need. So driving all of these factors has really driven some degree of information inequality, and we feel that something needs to be done to resolve that. The second challenge is to do with health and wellbeing. The Institute of Public Health in Ireland has clearly linked information inequality to adverse social outcomes. This is just a presentation that was done that was pointed to some research undertaken by the Healthwell in Ireland. And this information inequality doesn't just relate to transport or health related information, it's all information. There is a clear link between adverse social outcomes and information, and if it's disproportionately affects specific user groups, as we mentioned earlier, which has its roots in other socioeconomic divides, including education and employment-based factors. And breaking this chain really is key to opening up information access to all. The third challenge is around access. We mentioned earlier that there is a strong urban versus rural context. This is just another area where information inequality is playing out, and one of the main reasons for that is that there's a clear lack of infrastructure, and fixed infrastructure in particular, and wireless in rural areas, and that's in areas where the viability is not always well supported, in particular by a traditional business case approach. You know, if the economic viability doesn't stack up to put a fibre optic cable or satellite coverage in the East Cape of New Zealand, for example, oftentimes that infrastructure never finds its way there. And it's in those more urban areas, rural areas, I should say, that where critical lifelines are required in the event of a emergency, such as a tsunami alert. In some of these cases, being able to respond to a civil defence type emergency, it's highly reliant on accurate and timely information. So while there are some good tools that are available for getting these important messages out, and in the case here we're seeing a VMS sign in a rural community, semi-rural I should say, warning of a impending disaster. That's good, but it's not always available or useful, or information is not available or useful in terms of the more day-to-day information sharing, such as Twitter or Facebook feeds or what have you. So to deal with this, some older communication methods are still being used. There's a bit of a tongue-in-cheek example. I've got the old transistor radio. You can always rely on that to get the most up-to-date information, but clearly there's more modern practices that we can use, and satellite and cellular communications is coming along and will develop further, but clearly there is more that needs to be done in this space as well. So now we'll go back to Kirill and talk about some potential solutions.
Thanks, Steve. For areas where we see the improvements and support of the governments is required. First area is the pretty much analysis needs to be done. What really driving people desire for accessing information, what sort of information they want to access. Second one is the active modes. If we really want to change active modes to the, let's call it healthier ones, walking, cycling, we really need to provide information and provide people with ability to have that information. Third area is about the economic evaluation of the project, which it used to be until recently quite a difficult topic to assess economic viability of the project, especially if it's related to technology. Because we can't assess technology, we're really assessing benefits. And these days, approach called MBCM, or monetized benefit and cost approach, which allows us to include non-monetized and quantified technology benefits, will allow hopefully to go especially over the humps, especially in certain places and areas where it used to be definitely previously unrealistic to implement certain things. And of course, number 4, it's the government initiative and support. In New Zealand context, we're really talking about a regulatory and policy environment, pretty much what's driving implementation, all the above, and definitely will be the fundamental of making the equality achieved. Therefore, government really need to finalize the policy of digital inclusion. For all, standards need to be developed, programs set, KPIs defined, and we really need to go. Maybe I would add a little bit on the first one. We need to be ready to, especially in certain remote areas, which Steve touched on, whether it's rural or area where, let's say, remote areas, we need to go and sort of implement projects if they're not necessarily economically viable. We're talking about especially access to internet, installation of broadband, installation of Wi-Fi, installation of mobile network. While having all this, as I mentioned previously, will be a fundamental of accessing required information, and therefore gradually it will bring everybody to roughly the same level, hopefully. So that's what we wanted to say, and thanks very much. And if there are any questions.
Thank you, Kirill and Steve. That's yeah, some really good thought gone into it there. And yes, it clearly does come down to leadership from the top, doesn't it? We're waiting on some policies to give us this direction. And you've pointed out a number of times there the rural inequities, especially when it comes to technology. And I guess, you know, that's going to become increasingly visible when we start talking about in-vehicle technologies, when you've got this older fleet that we have here in New Zealand. Anything that you've put much thought to around that? You know, you had the example of the VMS sign in the East Coast there. You know, I guess that you think that maybe be able to be delivered, those kind of messages might come from your car, but obviously not everybody has that kind of car. So how else would you perhaps overcome those issues?
I'll have a crack at that. So there's some bridging technology that's available to make non-autonomous vehicles autonomous and actually get information into the vehicle. You know, even while the aging fleet catches up, and if there's a bit of a technology shift that puts us into EVs, and all of a sudden there's a commercial drive to actually get customers the information they need, having some of these devices which effectively turns a, for the want of a better word, a dumb vehicle into a level 2 or level 3 vehicle is a stepping stone along the way. And I think there's some pretty compelling information to demonstrate there's quite a sizable business case to value for money to spend $500 US on a box that you can put in your car and sort of bridge that gap between there and when the commercial and policy drivers are in place to deliver that.
Maybe I'll add a couple of points as well. Well, we all know that 5G is coming, and in previous researches, there was lots of time spent on sort of evaluating for 5G versus DSRC. And it looks like pretty much 5G, especially for safety critical applications, definitely going to be a tool. While it's clearly linked to item number 1, which I mentioned. So government really need to be able to go and play the sort of a role of the body who will subsidize, let's say, mobile installation, because they need to find the way, and of course talking to commercial world as well. Anyway, this is the initiative which is required. It will allow us to tackle all this, what you're talking about, the future autonomous and connected vehicles. Especially, it will not require certain infrastructure in place. It will allow to save costs.
Yeah, and lives as well, no doubt.
Oh,
right?
absolutely. Yes. And what I've seen recently, the telecom really started increasing the funding and availability of resources into rolling 5G. So that's another indication that really they watching it. They seeing latest technologies coming.
Okay. Yeah. I mean, yeah, it has the financial viability, but there's also,
But hey, there shall be government support, because of course it's always a sort of commercial organizations. If it's not viable for them, they're not going to roll. So government shall come and support.
So yeah, so quite a bit of work that needs to be done there to put.
But that's why you need policies to drive this.
Great.
Yeah.
Is there any other technologies that you guys are excited by that you see this being a barrier?
Steve?
Yeah, I'm just trying to think, Kirill. It really depends on the uptake, doesn't it? Making sure everyone's on the same page.
Maybe I can mention.
I think we talked about the economic viability. At some point, we've just got to bite the bullet and accept that getting information to people, irrespective of how uneconomic it is, it needs to be more of a strategic fit with the industrial roadmap, rather than whether the project flies on its own, because ultimately, when all the sums of the parts come together, it may actually form a viable solution, and then that unlocks the potential for more Bluetooth communication systems, enabling 5G coverage to reach more rural areas, just because there's other drivers there that we may not actually understand yet. Now, which I guess is why, prior the new approach to economics, the EEM was always releasing update factors and addendums, because things are always changing. So it's a moving target. So yeah, just thinking about it in terms of more than just the financial viability.
And maybe very briefly as well, you see simple thing as a mobile phone, especially these days, well, smart mobile phones. More people having them, more people having access to information. If we're talking about disability or other specific users, there's so many apps these days being developed. And again, I'm bringing my slide number 2 when we're saying access to ICT, information communication technology, pretty much is a fundamental for equality. So we need to find a way how more people will have access, how more people are able to have connectivity, to have more Wi-Fi's. It's a strategy, policies, plus implementations need to be supported by commercial organizations around the country.
Great. Yeah, I'm sure. Yeah, that goes far beyond transport alone, doesn't it? But,
absolutely, it's much wider. Absolutely, transport is one of the circles I pointed on diagram. Yes.
Excellent, guys. We've just hit 5:30, so I'm going to wrap it up there. I don't have any more questions from the audience there for you, but thank you so much for your thoughts and a great presentation there as well. So I would like to thank all of our presenters today and our audience. We will be making this webinar available on our YouTube channel shortly, and we'll also be contacting all of our attendees with instructions on how they can vote for their presenters, vote for the presenters that they thought were the best presenters from today's session and from last week's session as well. And so then hopefully we all see you at the AGM, we should be able to announce those winners. And hope to see you there as well, obviously, for the exciting announcement from Michael Wood on the Whakakotahi Innovation Fund, which hopefully will be, pushing things along, accelerating some of these solutions that we've touched on today. So thank you very much. Ka kite anō, and we hope to see you again soon, hopefully on Wednesday. Thank you very much, everyone.
Thank you, Simon.
Thank you.
Thanks, everybody. Bye-bye.
Thank you. Bye.